Good evening, guys.
Good evening.
One minute. Yes. So today, I'll be discussing an important part of this chapter, that is applications of derivatives, which is called as maxima and minima. Okay. Then I will explain approximation, because approximation, there is only one concept which needs to be applied. So last year they removed it in the deleted portion. But this year you have it. Okay, don't worry. This year you have it. I'm not saying they have removed it, but this is a simple one. So I thought I will explain the toughest part first, then I'll go to the simple one at the end. Okay. So the topic that we are going to discuss today is maxima and minima. Okay. So as the name suggests, okay, what do you mean by maxima? Maxima is a point of maximum. So maximum is singular. Maxima is plural, as simple as that. So the plural of all the maximum points on a curve is what we call it as maxima. Similarly, if you have minimum, the plural of all these points is what we call it as minimum. This plural, this singular. Okay. Now what we are going to do is, we are going to take the help of derivatives to understand the concept of maxima and minima. Let's see how to do it. So please make a note of this point first. So these are called as some derivative tests. So we will be testing using the operation of differentiation to understand if the given function is having a point of maxima or minima at a given location. So if I take this point as a comma 0, if I take this point as a comma 0, then what can I say is this function having y is equal to f of x having at point capital A? Can I say that the function is decreasing and then increasing? So this is decreasing and then increasing. So when this is happening, can I say this is the point of minimum? Can I say that, guys? So it is a point of minimum, right? So at the point of minimum, what is going to happen is, you try to draw a tangent to the curve anywhere on the left of it, and you try to draw the tangent to the curve anywhere on the right of it. Then observe this carefully. If I take this as theta, and if I take this, okay, I'll take this as alpha. Alpha and beta both are measured in the anti-clockwise direction. Then if I call this as L1 and this as L2, what is going to be the slope of L1? It will be tan alpha. Look at the angle and tell me whether tan alpha is going to generate a positive value or a negative value or zero value. So tan alpha, tan of alpha, is alpha an acute angle or an obtuse angle?
Obtuse.
So obtuse angle means what will happen? Tan will generate a negative value. Just a minute, it will come. So tan will generate a negative value. Similarly, what is slope of L2? Tan beta. So tan beta is acute, which is positive. Since alpha is obtuse, since alpha is acute. Am I right? So as we move from left to right, if the slope of graph changes from negative to positive, then there is a point of minimum. As we move from left to right, as we move from left to right with respect to a point, and if the slope of graph changes from negative to positive, then the given point is a point of minimum. Then the given point is a point of minimum. Okay. Listen. Similarly, shall I proceed?
Yes, sir.
Similarly, if I have a curve like this, if I have a curve in this way, okay, what is happening here? It is first increasing and then it is decreasing, right? So when I draw a tangent at a particular point, so if I take this point as the reference point as a comma 0, and this is y is equal to f of x. So on the left of a, if I take this angle to be alpha, and the right of a, if I take this angle to be beta, okay? So what is tan alpha? L1, L2. So what is slope of L1, guys? Tan alpha, and tan alpha is positive. What about slope of L2? That is tan beta, which is negative. At a given point, when we move from left to right, if slope of graph changes from positive to negative, the given point is point of maximum. Okay, don't worry, it is not this complicated every time. This is how they start actually. First is you do the slope test, that is the derivative test on left of the point and right of the point, and try to understand what is happening. But there is another easier way also, don't worry. Since I have to teach the concept, I'm explaining everything. Okay. Shall I proceed?
Yes, sir.
Verify whether x equal to 0 is a point of maxima or minimum. I can say maximum or minimum for the curve y is equal to x square. So what are we supposed to do? First, find dy by dx, that is 2x. So find dy by dx for a value x less than 0. Why did I take less than 0? Because 0 is the limiting point. On the left of 0, what should I have? 2 into, I can take minus 1, minus 1. As I told you, it can be any point. It need not be minus 0.5, something like that. 2 into take any value, it is minus 2. Okay. Similarly, dy by dx for x greater than 0, can I take 2 into 1, which is 2? So f dash of x changes from where to where? It changes from
Negative to positive.
negative to positive. So what will it give us? It will give us the point of
Minimum. Maximum.
no, it is point of minimum. It will give you the point of minimum. It's very simple. Y is equal to x square is nothing but an upward parabola. So if I take this point as 0, 0, the curve is first decreasing and increasing. So this point is the least point. Minimum means nothing. That is the least function value that you can find. That is what I'm trying to say.
Sir?
Tell me.
Sir, is it always applicable for like to apply that negative x is less than 0 first and x is greater than 0 first? What will happen if I do that x greater than 0 condition in the first, sir? What if I apply that x? So then it will be maximum, no, sir?
You can do it.
So then it will be maximum, no, sir?
No. That is not the case. You should always go from left to right. You should always go from left to right because that is how we write the real numbers, no? You write minus infinity to infinity or infinity to minus infinity.
Minus infinity to infinity.
That is why you are coming from left to right, no? That's what we follow here also. That is the reason I told you have to move from left to right.
Okay, sir.
Okay. So that is how we do other problems also. Now, as I told you, there is an easier way to find the answer for it. Let's see how we can solve it. Okay. So it's very simple. Listen. It's called as the method to verify the point of maximum or minimum. So we are again going to apply the concepts of applications or concepts of derivatives only. See, we concentrated on what is happening on the left of a given point and right of a given point. But if you observe what is going to happen exactly at the point. See, for example, looking at this graph, tell me what is this? This is the point of
Minimum.
minimum. Right? So when it is a point of minimum, What will happen if you draw a tangent exactly at the point of minimum?
Parallel
Sir,
to the
because tangent of the
x-axis.
It is parallel to x-axis, right?
X-axis.
So can I say f dash of x is 0?
yes, sir.
So instead of finding f dash of x on left of a given point and right of a given point, I will just find f dash of x and equate it to 0, so that I will understand whether it is a point of minimum or not. But here comes another important, here comes a big problem. What is it? If you have a function like this, okay, and this is the point of maximum. So at the point of maximum, if you draw a tangent, still so if you draw a tangent at the topmost point, that is at the point of maximum, still you will have f dash of x to be 0. So what is the confusion that is getting arised here? Unlike the previous case. So when you find the derivative of f of x at a given point and equate it to 0, and if it comes out to be 0, then there is a high possibility that the point can either be a point of minimum or a point of maximum also, right? So this is called as the first derivative test. Okay, this is called as the first derivative test. In order to overcome this discrepancy, what they have done is they have come up with a concept of a second derivative test also, which makes use of the limits concept, where they say something like this. The second derivative test is like this. Find f double dash of x, and if it comes out to be greater than 0, then x is the point of minimum. X is a point of minimum. Okay. So the proof for this comes from the first principle of derivative, which is not needed for us. You can accept it. So f double dash of x is greater than 0. And if the second derivative test says that if f double dash of x at the value of x is greater than 0, then it is a point of minimum. Similarly, if f double dash of x is less than 0, then x is the point of maximum. Okay.
So I have a doubt.
Tell me.
What if the second derivative is equal to 0, sir?
It's called point of inflection. I'll come to that.
Okay, sir.
Okay. Now, let me take an example and show you the to you first. So same example, y is equal to x square at x is equal to 0. So what you can do is f dash of x is 2x. So 2x will be equal to 0, right? So x equal
Yes,
to
sir.
0. So I'm getting one thing. At x is equal to 0, f dash of x is 0 for sure. So f dash of x, if I equated it to 0, then I got the value where f dash of x gives out to be 0 at x is equal to 0. Okay, first point. The second point to be noted here is what is f double dash of x? It is 2.
Sir, 2, sir.
When f double dash of x is greater than 0, then it should be a point of
Minimum.
minimum. That is what we got in the previous case. Are you able to understand? So this is what happens. Similarly, you can try out for y is equal to x square minus 2x plus 3 and tell me what is the answer. I'll give you 1 minute time. Do it guys. Yeah.
Yes.
What is the answer? So you would have got 2x.
Point of minimum.
So what point is the point of minimum? X equal to
1.
1, sir.
yes. So f dash of x is 2x minus 2 equated to 0. This you will do for maximum or minimum. So 2x is equal to 2 means x will be equal to 1. Then what will be the value of f double dash of x? It is 2. So if double dash of x is 2 is greater than 0, it will be a point of minimum. I hope you're able to understand this, right? So let's go to the textbook and see. So this is the first thing that I explained. Okay, increasing, decreasing, decreasing, increasing. See, actually, what there is nothing but whatever we have learned in Rolle's theorem. Okay, so f dash of x changes sign from positive to negative as x increases through C. Then f dash of x is greater than 0 at every point sufficiently close to and on the left of C. F dash of x is less than 0 at every point sufficiently close to and the right of C. And the point is called as the local maxima. So this is the first derivative test which I told you. Right. Similarly, f dash of x changes the sign from negative to positive, then you will have the point of minima. If f dash of x does not change the sign of x as x increases through C, then C is neither called as a point of local maxima or point of local minima, and that point of such a point is called as a point of inflection. Okay. Secondly, sorry guys, one small change, small correction in what I told. There is actually, this whole thing is called as the second derivative test. Sorry. This whole thing is called as the second derivative test. And the first one where we use the sign convention is what is called as the first derivative test. It's called as the first derivative test. Please make this correction. I'm sorry. So first derivative test is the one where we check the sign of f dash of x changing from left of C and right of C. Whereas the second derivative test is the one where you're checking the sign of the second derivative. Okay. Now, to answer your question, listen. So if at x is equal to C, it is a point of local maxima if f dash of C is 0 and f double dash of C is less than 0. Similarly, at x is equal to C, the point is called local minima if f dash of C is equal to 0 and f double dash of C is greater than 0. Suppose you get f dash of C also to be 0, f double dash of C also to be 0, then what will happen is this test fails. The second derivative test fails. Then what we need to do is we need to go back to the first derivative test and find whether C is a point of local maxima, local minima, or point of inflection. That is what you need to do. Rohan, I hope you got the answer. Tell me now.
So the second order derivative, it is independent of the positive and negative sign, sir.
which independent of which positive and which negative.
Sir, that is if we like do the second order derivative of any, for example, here it's a 2x minus 2, we got 2, sir. So is the
Okay.
answer dependent or independent on the positive negative sign, sir?
Listen, means I have to clear this. So I gave you a function, no? So that x square, or the function x square minus 2x plus 3. So this is f of x. What did you do? You took f dash of x, no? That is 2x minus 2. Okay. So f dash of, after you find f dash of x, you equate it to 0. In the second exercise, if you remember, if I write f dash of x to be greater than 0, so what do I indirectly mean by it? I'm trying to say that the function is increasing. Do you guys remember this? Similarly, if I write f dash of x to be less than 0, what am I trying to say? The function is decreasing. I told you the reason at that point in time itself. So this is from exercise 6.2. In a similar way, for a given function, if you differentiate and equate it to 0, then you are equating it to 0 for what condition? For a condition of maximum or minimum. Mithun, is it clear till this step? Means
Yes, sir.
you differentiate something, you differentiate a function, first derivative, okay, not the second derivative. You differentiate the given function once and equate it to 0, then anybody will understand that you're trying to find what is the value of x at which f dash of x is becoming 0. Or to put it in a statement, what is the value of x at which the function attains a maximum or minimum. Okay, this is based on the second derivative test. So after this, f double dash of x, you're doing no. So you would have got a value of x from here. For example, in this problem, you got the value of x as 1. If suppose you find f double dash of 1 and it comes out to be greater than 0, then 1 is a point of maximum or minimum.
Minima, sir.
So it's a point of minimum. So this is what you need to see. So to answer your question, sign will come into picture only in the case of second derivative. Okay. I hope you're clear with the correction that I made. Since you're doing f dash of x equal to 0, this method is not called as the first derivative test. Please make that correction.
Sir,
So,
in that, sir, in the f dash of x method, we found a value for x, right? Sir, x as 1. Sir, in
yes, you got the
here
value.
itself we can conclude the answer, right, sir, as minimum or maximum.
How?
Because here x is greater than 0. No, sir, value of x is greater than 0.
No
Right,
need.
sir?
No need. The value of x, the sign of x will not decide whether it is a point of maximum or minimum. That has nothing to do. That is why I explained it graphically. See, what is the basic meaning of f dash of x? F dash of x means slope of a tangent at a given point. So for a curve, if you draw a tangent at a particular point, and if the tangent is parallel to x axis, then I can say f dash of x is 0. Are you clear till this step?
Yes, sir.
Okay. So f dash of x is equal to 0 can be attained for a curve which has a local minima, or for a curve which has a local maxima also. So when mathematically f dash of x is equal to 0 can give you any of the possibility, means you have only 50% chances. To get that 100% chance only, we are going for the second derivative test. So what I'm trying to say here is, remove the concept of this thing from your mind. Since x is positive, from there itself I can conclude no. So
Okay,
f dash of x is equal to 0 is applicable for both the condition of minimum as well as maximum. Okay. Do some more problems, you'll
Yeah, I have
understand.
a
So tell me.
So f dash of x is equal to 0, sir, in case of
Rohan, your voice is breaking.
we said a test is failed. If
No, no,
f
can you
dash
repeat
of x
again?
is equal to 0, sir, in second
Okay.
derivative test, that means the
Okay.
test is failed. What does that mean actually, sir? The test fails.
No. Okay. I'll do one thing. I think there is a confusion for you guys. I'll put it as a block diagram. Then I will explain what is the meaning of it. So first derivative test, what you do is f dash of x changes sign from negative to positive. It's the point of minimum. Okay. F dash of x changes sign from positive to negative, then this is the point of maximum. Okay, so f dash of x changes sign from positive to negative. It is the point of maximum. I hope this point is clear, right? Listen.
Yes, sir.
So in the first derivative test, what have they given? If f dash of x does not change the sign as x increases through c, then c is neither a point of maxima. So if there is no change of sign, then it is called as the point of inflection. And some books write it as INFLEXION also. Okay, that's also fine. So whereas in the second derivative test, f dash of x is equal to 0 and f double dash of x is greater than 0, then it will be the point of minimum. Okay. Similarly, f dash of x is 0, f double dash of x is less than 0, then this will be the point of maximum. F dash of x is 0, if double dash of x also comes out to be 0, then this test fails. The meaning of this test failing is it is not satisfying either of the conditions. Okay, so there is nothing like third derivative test which is going to tell you whether it is a point of minimum or maximum. So if these two conditions are attained for a particular problem, then you should accept that this second derivative test has not worked in your case to find out whether the given point is a point of minimum or maximum. Then what you do is you go back to the first derivative test and find the change in sign of the slope. Rohan, I hope I answered your question.
Yes, sir. Now it's clear.
Okay. Please prepare a chart like this so that you'll understand. Okay, shall I proceed? Now listen. So there are two types of questions. If you see this question, find the maximum and the minimum values. So maximum and minimum values mean function value. Guys, I hope you're able to understand. When they say find the maximum and minimum values, you need to find the function value at the point of maximum or minimum. Or sometimes the questions will be like this. Find the points of maximum and minimum. At that time, you can stop with the derivative test. Okay. So the given function is f of x is equal to x square. The solution is f of x is x square. What is f dash of x? It is 2x. And I will equate this 2x to 0. Then I will get x is equal to 0. Accepted. Okay. So x is equal to 0 is the point of this we have already done many times. So f double dash of x is 2 greater than 0. So it is a point of minimum. So what will be the minimum value of function? What will be the minimum value of function? Is it not going to be f of 0? Because at x is equal to 0, you are getting a minimum value. So what is going to be the value of f of 0? It is going to be 0. Then what is going to be the maximum value, guys? Where is it becoming maximum? If you look at this curve, at infinity. So it is going to be infinity. So the minimum value is 0 and the maximum value is infinite. Okay. Next. You guys do this. Find the maximum and the minimum values of f if any of the function given by f of x is equal to mod x for all values of x that belongs to R. This I've told many times. So how will you define mod x? You will define it like this. So what is f dash of x?
1 minus 1 and 0.
So where is f dash of x equal to 0? At x equal to 0. Right? So what is f double dash of x?
It's 0 for all cases. Sir.
So it is going to be 0 for all the cases, right? Here, Rohan, you will understand it better. See, f dash of x is coming out to be 0 at x is equal to 0. And f double dash of x is also coming out to be 0 at x is equal to 0. So what can we conclude? Second derivative test. Yes. So what are we supposed to do now?
Go to f dash of x and check the sign changes up.
Yes. You have to go back to f dash of x and check the same changes of sign. So you need not do it again. F dash of x, observe 0, lesser than 0, greater than 0. So here f dash of x for x less than 0 is how much? It is negative. F dash of x for x greater than 0 is positive. So if the value changes from negative to positive, it is the value changes from negative to positive. It is a point of, so x
Minimum.
equal to 0. It's a point of minimum. Okay. So this is called as the point of minimum. Clear, guys?
Clear, sir.
Yes, sir.
Right. Now, what is the point of maximum? So x belongs to R, minus infinity to infinity. Okay. So you are getting the point of minimum somewhere between minus infinity and infinity. That is at 0. So what is going to be the maximum value? Infinite. And that is obviously clear because what is the graph for f of x is equal to mod x? This is not a shape like this. So the least value is available at 0, 0, and the maximum value is obviously going to be infinity. Am I clear, guys?
Yes, sir.
Okay. Find the maximum and minimum values if any of the function given by f of x is equal to x for all values of x that belongs to 0 to 1. So the most ignored part is the domain. Many of them don't look at the domain and they will take f of x is equal to x and they will take the whole values. Don't do that mistake, okay? So f of x is x, f dash of x will be how much?
1, sir.
1. So there is no possibility of f dash of x to be equal to 0 at all. Right? It is going to be 1. There is no possibility of it to become 0. Hence, the minimum value. Okay. One more important point. F dash of x is equal to 1. It is greater than 0. So what can I say about this function? It is an increasing function. It is an increasing function. So the minimum value is possible at the left extreme of domain. That is how much?
0, sir.
0. And maximum value is possible at x equal to 1. So what is going to be the value? F of 1 will be 1. Okay. 1 minute. Let me see how they have done it. Okay. So one thing, actually I made a mistake. I had a doubt and I wanted to check. You know, had the question been x belongs to 0 to 1, then these would have been the answers. But unfortunately here, what is happening?
It doesn't
Yes.
take place at 0, sir.
That doesn't take 0 and 1, so it is not possible for us to write. You just have to conclude saying that it neither has a minimum value nor a maximum value. That's it. Because you can't conclude, no, it is an open circle. It is a discontinuous function at x equal to 0 and x equal to 1. See, that's what they have given. See, the reader may observe that in example 25, if we include the points 0 and 1, then we can extend the domain of f to 0 to 1. Then the function has minimum value at x is equal to 0 and maximum value at x is equal to 1. In fact, we have the following results. The proof of these results are beyond the scope of this present text. You're able to understand? So the only thing is, since 0, 1 are present within the open interval, it does not have any point of minimum or maximum. So this is wrong. Whereas in the previous problem, it would have been right because that point would have been included in it. Okay. Next, find all the points of local maximum and local minimum of the function given by this thing. So f of x is equal to x cube minus 3x plus 3. So what is f dash of x? 3x square minus 3. So f dash of x is equal to 3 into x square minus 1 and equated to 0 for maximum or minimum. Okay. So x square minus 1 will be equal to 0. What is the value of x? It is plus or minus 1. So x is equal to 1 or x is equal to minus 1. Now, what are we supposed to do? They are asking us to find which point is maximum and which point is minimum. So f double dash of x is equal to 6x. So what is f double dash of 1? It is 6. F double dash of minus 1 is minus 6. So this is greater than 0, this is less than 0. This will be the point of minimum, and this will be the point of maximum. So x equal to 1 is minimum, x equal to minus 1 is maximum. Okay.
Yes, sir.
Next. Find all the points of local maximum and local minima of the function given by this thing. So f dash of x is equal to 6x square minus 12x plus 6. So f dash of x is equal to 0 for the condition of maximum or minimum. X square minus 2x plus 1 equal to 0. So it will be x minus 1 the whole square is 0, which implies x is equal to 1. So what is f double dash of x? 12x minus 2. So substitute it here, it will be 0. So what do you understand from this? Wait. So f dash of x is 0. 6 into x square minus 2x plus 1 is equal to 0. X minus 1 the whole square is. Okay. F dash of x is 0 at x is equal to 1, and f double dash of x is also 0 at x is equal to 1. So the only option that you're left out with is you need to go with the first derivative test. At which point? At x is equal to 1. So if the f dash of 1 minus is how much?
Zero,
F dash,
sir.
sorry,
Will be 0.
f dash of 1 minus. 1 minus means take a value less than 1 and substitute it. No? You can take
Be 6,
point.
sir.
Huh? Is it
If
negative
you
or
take
positive?
0, it will be positive, sir.
You want to take 0. You take a slightly lesser value. No? 3 by 4 something. So f dash of 1 minus, you are getting greater than 0. Huh? What about f dash of 1 plus?
It's also positive, sir.
That is also positive. Huh?
If we
So it
take
should be
x equal to 2.
then it should be a point of inflection. This one, no? Yes. So x is equal to 1 is a point of inflection. Did you understand? So when
Yes,
you take
sir.
f dash of 1 minus and f dash of 1 plus, since the sign is not changing, This will be the point of inflection. This one. Find the local minimum value of the function given by f of x is equal to 3 plus mod x.
So the last question answer is point of inflection, right, sir?
Yes, it is.
Okay, sir.
Okay. So find the local minimum value of the function given by this thing. F of x is equal to 3 plus mod x. So what is f dash of x? Guys, I just want to tell you one thing, that if f of x is equal to mod x, derivative of f dash, derivative of mod x is mod x by x. Please make a note of it. Derivative of mod x is mod x divided by x. Okay. That is one. I just gave you an information. So similarly, how can you define f of x as? Can you write it as 3 plus x for x greater than 0, 3 minus x for x less than 0, 3 for x equal to 0? Right. So what is going to be the value of f dash of x? One minus 1, 0 for x greater than 0, x less than 0, x equal to 0. Tell me one thing, is everyone clear with this step?
Yes, sir. Yeah.
Now tell me, what is f double dash of x? 0, 0, 0. So again, this test fails. Now we need to go to the first derivative test. In the first derivative test, for the value of x less than 0, it is negative. And for the value of x greater than 0, it is positive. So when the value changes from negative to positive, x equal to 0 is the point of minimum. Right. So what will be the minimum value of this function? The question is, find local minimum value of the function. So local minimum can be found at f of at x is equal to 0. What is f of 0? 3 plus 0. Answer will be 3. So the local minimum value is obtained for this function at x is equal to 0, and the value comes out to be 3.
Sir, how x less than 0 is 0, sir?
Where? This one.
Above, sir, where you took the first derivative test.
X less than 0, it is negative, no? Minus 1, no? This is f dash. So f dash
Yes,
of
sir.
x for x greater than 0 is positive. For x less than 0 is negative. At x is equal to 0 is 0.
Yes, sir. Then the point of minimum should be, how, sir? Point of minimum is 3. Should be minus 1, right, sir?
Okay, 3 plus 0.
Okay, okay, sir.
Okay. So the remaining problems we'll do it tomorrow. Okay. Is there any other doubt from today's class?
No doubt, sir.
Okay.
No
Okay, then
doubt,
I'll
sir.
see you guys tomorrow. Yeah. See you all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.